What we're going to focus on in this video is graphing the variations of sine, meaning that the actual equation is going to be multiplied, divided, added, subtracted by something, and it's going to change the original parent function of the sine graph. The ultimate variation of sine, we've seen that y usually equals the sine of just x. Now, what we can actually do is multiply that by something. We can multiply the x by something, so it would be sine of bx, or we can subtract something in the parentheses, and we can also add or subtract something on the outside. So we can do 4 things, A, B, C, D, to our sine graph. Now, some of your problems will have all 4 of these. Some of them only have 1 or 2, any combination. So you really need to look at each part and decide what is happening. Now, each of these new variables, A, B, C, D, mean something different. The first variable, A, is our amplitude. You need to be able to find that. This is going to be a quick check for you to make sure you are graphing correctly. How we find that is always the absolute value of whatever A is. If it's -3 times the sine, the amplitude is actually just +3. And for sine, remember, that's the distance from the x-axis to the maximum point. So that should be a distance of 3, and that's going to help us out. Now, for a sine graph, we have the period, or one cycle. From start to finish, it kind of afterwards will repeat again. We can copy and paste this section over and over, and the graph will continue to make this wave. How we find that is always, for sine, that is always 360 degrees. But if we introduce this b value, that period is going to change. So we're going to actually take 360 and divide it by b. That answer is going to be the distance of the entire one cycle. Then we also have a phase shift. A phase shift is going to take the whole graph and just move it left or right. And I'm going to write that right here. So it's going to move left or right. And how we determine that is we take the value of C and divide it by B. What's really important about this C value, especially if you notice right up here in our equation, is that the formula says minus C, which means to find the phase shift, the value here is going to be opposite of what we see. Therefore, if you see a -3 in the equation, over here to find your phase shift, you're going to write a +3. If you see +3 in the equation, for phase shift, you're going to write -3, opposite. And the last thing is we're going to have a vertical shift, which it's meaning the whole graph is going to move up or down, and that is just going to be determined by that last variable. If that last number is positive, it will move up. If that last number is negative, everything's going to move down that many units. If it's -5, everything will move down 5. So let's go ahead and take a look at an example. This one is going to involve all 4 of these things, A, B, C, and D. On your assignment, One of them might involve all four, but the first one may just use one or two. So make sure you look at each individual part. So here's our example for today. All right, so when you start this off, maybe off to the side, say what each variable is. And remember, C is opposite of what's written up there, so it's actually going to be a positive 120, and D is a negative 1. So remember, A stands for our amplitude, B is going to help us find the length of the period, C is going to help us find our phase shift, and D is the vertical shift. So the first thing that we want to do is kind of write all those things down. Our amplitude, I'm going to write like part A here. Step 1. Our amplitude is going to be the absolute value of 4, which is 4. So if we're graphing this, the distance between the x-axis and the maximum and minimum should be 4 units. So make sure you watch that. Even if we shift the graph vertically, so maybe it's like here, then kind of our new x-axis is going to be there, and the amplitude there should still be 4. We also need to find the period of this graph. Sine usually has a period of 360 degrees, and to find it, we just divide by b. The value for b in this case is 2, so now our period is actually 180 degrees. So what has happened, instead of being at 360, it's now cut that in half. So we've kind of shrunk this, kind of compressed it in on each other, like take your hands and try to clap together. That's what we're doing to the graph. We're compressing it. Instead of it being like this, we're now going to compress it so it's a little bit more like that. Next, we're going to talk about our phase shift. I'm going to write PS for phase shift. And how we find this is we're going to take C divided by B. Remember, C is opposite of what you see. In the equation, we see a negative 120. So we're going to write positive 120 and divide it by 2. So it's going to be 60, meaning we're not starting at 0. We're actually moving our graph over horizontally 60 degrees. And the last thing is our vertical shift, VS for short, and that's just a negative 1. And the negative means that the graph is going to move down 1 unit. If it was positive, it would move up number of units. So this is all very, very important to know. What's also really, really important is that our phase shift. This is where the cycle is going to start. Usually sine starts at 0 and goes to 360. This time we're going to start at 60 degrees and we're going to go a certain distance. All right. Kind of part 2 now. We need to look at some key points in our graph. Now, if you remember back to the parent function of sine, looks something like this. We had a few key points. All these zeros here, and then our max and minimum. There are 5 key points on any sine function. So we don't need to find all those extra points. We just need to find these 5. And if you notice, if we kind of cut the graph on each of those 5 key points, there are only 4 sections. 1 section, 2, 3, and 4. So the 5 points have actually cut our graph into quarters, which is really interesting. So to find our 5 key points, we need to first find the quarters. To do this, we need to take the period that we just found before and cut it into 4 equal parts, into our quarters. Think about like a football game. There are 4 quarters. We have to find the total time and cut it into 4. So our total time, our period, was 180 degrees. If we try to divide that by 4, that actually equals just 45 degrees. So each section was 45 degrees, just like that. And that'll add up to equal our entire 180 for the entire period of this function, of this graph. So now we actually need to find those points. So the first one is always going to be what the phase shift said. So phase shift, answer goes here. And that was 60 degrees. To find our second key point, we take the previous answer and now add our quarter, which our quarter this time was 45. And we keep doing that. Take the previous answer and add our quarter. Until we get our 5th number. These numbers here are our 5 key points, x1 through x sub 5. So we found 5 x values. Now we need to find the corresponding y values. All right, which brings us to part C. We need to find our coordinates, all 5 of them, to graph. This is what I like to do. I kind of like to make a chart, makes my work very organized. So I'm going to start with x sub 1, which was 60 degrees. I'm going to take this number and substitute it into our equation, the one we started with, which if you remember was 4 times sine of 2 times x, which we're saying is 60 in this case, minus 120, and your parenthesis, and then minus 1. Now you probably have a little bit more room on your paper. Make sure you write small to utilize all the space. But we're just going to solve this. So we need to simplify. The first thing we're going to simplify is everything inside the parentheses. That's the most important. So it's still going to be 4 sine of all this stuff minus 1 on the outside. So if we notice 2 times 60 is 120. And if we were to subtract those 2 numbers, 0 is what's left. Now, if you type sine of 0 into your calculator, your actual answer is 0. 4 times 0 minus 1 actually gives us an answer of -1. That's the y value of this coordinate. So one coordinate you are going to graph is 60, comma, -1. Now I wish I had more room, because then right under this I would write the second key point right here in this bottom corner and keep doing this. Keep substituting all 5 key points into our original equation. I don't have room for that, so I'm going to erase. You don't erase, but I will. Now our second key point was 105 degrees. You're going to do the exact same thing. Substitute. And then you'll solve. Look at what's in parentheses and simplify everything there. That actually comes out to be sine of 180. That actually comes out to be -1 as well. I'm sorry, I seem to have messed up here. It's not 180. 2 times 105 minus 120 is actually 90. Then I find the sine of 90, and that's actually 1. So 4 times 1 minus 1 will give us the answer of 3. So that's another coordinate that we have, 105, comma 3. That's another thing that we are going to write. And you need to keep doing this with all 5 key points. Now, after you finish finding all the y values for all your key points, this is what you should come up with. So we substituted all our x values into the equation, and all our y values is what we got out of that, was the output. Now these are the 5 points that you are going to draw. On your assignment, you'll see graphs that look like this, and there are actually no numbers on the x-axis. What you need to do is decide, well, how far do we need to go? Maybe this last one is 300, and the one in the middle will be 150. You need to make sure everything is spread out evenly. What we do not want is to this be 100 here and then this other number to be 300. Because then you're telling me this distance is only 100, but then this distance is 200. That doesn't make sense for us. So make sure it's very even. What you kind of notice is your first, middle, and last y values should be the same. That's kind of like our x-axis here with the amplitude, looking at that. But we know we had a vertical shift, so everything here got moved down 1, like so. That's going to be a clue for us. And then the amplitude should be 4. So from this middle line up to the maximum should be 4. So from -1 to 3 is good, and from -1 to -5 is also 4. So that is good. Now I don't have the best system for graphing here, but you just need to go ahead and find where 60 degrees is and plot your points. And just make sure all your graphs are evenly spaced. So your graph should look something like that here. Just go ahead and try your best, and you should be fine.